Arguments with Euler diagrams.
This is what, 3/8?
It looks like it's spelled Euler, but it's actually pronounced Euler. It's a French name, I guess. One of the better mathematicians of all time. And these kind of arguments deal with the other possibility. What's the other possibility? Well, if you don't have an if-then, and if and only if, and or, we go back to that first lesson which we were talking about global statements. All and, some and none, those type of things. So this will be the, if you want to think about it, the global arguments. When we start talking about the words all, some, none, no, things like that. You cannot do a truth table for these. When you see the words all and some, you cannot do a truth table because I've never shown you a truth table with all or some. The only ones you know are and, or, if, then, if, and only if. That's it. So the arguments look like this. All computers are electric powered machines. All electric powered machines are expensive. Therefore, all computers are expensive. Now be really careful. You do not want to bring in any knowledge into these problems. If I tell you a lion is safe, then the lion must be safe. Don't assume anything. So whether it's safe or dangerous, you don't care. You're just going to go by what they're telling you. Remember, logic makes absolutely no sense, and it's not supposed to. Not when we're just randomly generating. All right, so this would be the logical argument that is not an if-then, not an and, not an or, not like before. So there's not going to be a truth table set up for this one at all. So there's got to be a way of doing it. And the way we're going to do it is, technically, we're going to go back to Venn diagrams. Remember Venn diagrams?
Yeah, the little circle thing.
The little circle things. So if I say all A's are B's, go back to set notation, set A and set B. When you say all A's are B's, how would you draw the Venn diagram?
A inside of one circle.
A has to go inside of B?
Yeah.
Yeah. So the big circle would be the set B, the little circle would be the set A. Therefore, any A that you pick happens to also be a B, also known as A is a subset of B. But we're in logic land here, so we want to phrase it as all. All right, what if I said no A's are B's? Side by side, better known as disjoint. So here's A and there's B. They have nothing in common. All right, so one of them is all, the other one is no, the last one, of course, is some. Some A's are B's. What kind of circles do I get? Two intersecting circles. So here's A, here's B, and they share a couple things. All right, so when I bring that kind of idea back into this logical statement, and I'm saying all computers are electric-powered machines, you have to first recognize the two ideas. If you don't see the two ideas, you're not going to be able to draw any picture that goes with them. So if I say all computers are electric-powered machines, which circle is bigger? The powered machines, because it comes in the second place. Just like over here, all A's are B's. B's came second, but it became the big circle, and the first one goes inside of it. So when we're drawing this, we start with this is the big circle, and this one is the small circle, because that's how all works. So the big circle is going to be electric-powered machines. And you can abbreviate it as long as you know what the heck that circle is talking about. So all the electric-powered machines in the world go in that green circle. What else goes in that green circle? All these computers, because it says all computers are electric-powered machines. So computers go in here. Computers. Okay. So every computer I pick, wherever it is, has to be in this blue circle. But if it's in the blue circle, it's automatically in the green circle. So we're all set. All my computers are electric-powered machines. And you never ever switch the order of these things. It's always big is the second one and small is the first one. Just don't even worry about what the words are. It's big is the second one, small is the first one. Now the second sentence, we've only done the first sentence now. Now you go to the second one. Don't try to mix and match these things. One sentence at a time. All electric-powered machines are expensive. Now remember, the second part of this is the big. So electric-powered machine, expensive is the big part. So the small part is the electric-powered things. So if electric-powered machines is the small part, that's the green circle.
You gotta draw one bigger than that one.
I gotta draw one bigger than that one, and it has to go outside of electric-powered machines. So this big black circle is expensive. And anything that is inside this black circle is also expensive. So therefore, all computers are expensive. Makes sense, because if I pick a computer, it happens to be an electric-powered machine, which also happens to be. And the goal of this is, if I pick one computer, I can't draw it anywhere else. If I pick this computer, it is in here, guaranteed without a doubt, and it can't go anywhere else. One picture, the answer becomes valid. That's your goal. If you are forced to draw one picture, the argument is valid. So guess what? If you can draw two different pictures that mean the same thing, it has to be invalid, because then you don't know where things are. Try.
Okay, electric power
Machines.
that we just circled.
It came in
supposed
the.
to put that somewhere?
We did. It's already on the paper from the first
Electric
sentence.
machine. Okay.
Yeah, you don't want to draw two circles that represent electric-powered machines. If I already have it drawn, I'm done with it.
Okay. So
You draw it once and you're done.
electric power. What electric machine?
Yeah.
Okay.
Electric-powered machines, electric-powered machines. I don't have to copy it down twice.
Okay. So did we even have to bother it then?
Well,
Electric power.
yeah, I did. It becomes my connector between my computers and my expensive.
Okay.
It connects them in some fashion or form.
Mr. Carr?
Yep.
What do you mean by two different pictures?
Oh, we're getting there. I'll show you.
Oh,
I'll show you. It's hard to describe until you actually see one. For instance, this is like my favorite one. All cats spit hairballs. And if you've ever seen it done, it's gross.
It is.
It's absolutely disgusting. Sammy spits hairballs.
Sammy's okay.
Therefore, Sammy must be a cat. Therefore, Sammy is a cat. Woohoo! Now, the laws of drawing the circles do not change. You have to draw one sentence at a time, and you have to follow the all, none, some ways of drawing the pictures. So, right off the bat, you have to find the two ideas in this first sentence. Cats is one of them. Hairballs is the second one. Hairballs falls second, so this must be the big one. And cats fall first, so that must be the small one. So when I draw it, hairballs is going to go first. I always draw the big one first. Spitting hairballs. And inside it must be cats. The marker good.
So the small one, the circle that goes in the middle.
Well, I wouldn't say in the middle, but inside the first one. It's the smaller of the two circles. Only with the word all. Okay, so when you look at this, every single cat you pick is going to be spitting hairballs. What if you're outside the cats but still in hairballs?
And you're not a cat, but you spit hairball.
Yeah, you're not a cat, but you're still spitting hairballs. Excuse me. That hairball. So, we get to the second part of the sentence, and it says, Sammy spits hairballs. So where do I put Sammy in my picture?
Inside a cat.
I can put her inside a cat, so here's Sammy. Let's say X equals Sammy. Is that the only place Sammy can go?
No. Outside of cats, but inside of hairball.
Because she could be spitting hairballs, but not necessarily being a cat. So how many pictures did I just draw for Sammy? 2. She can't be in 2 different places at once. So this argument is invalid. And that's all there is to these Euler diagrams. If you can draw one picture, valid. If you could draw 2 different pictures or 2 different situations, guaranteed invalid. Let's do an ugly one. Some people like hot dogs. Some people like hamburgers. Do you care? No. Therefore, what do you think would be a decent conclusion here?
Hamburgers and
Therefore,
hot dogs.
people like food.
They like both of them. Yeah, food isn't up here.
Hot dogs.
Some people
Like me.
like both. Or some people like hamburgers and hot dogs. I don't know what's going to happen to this one. So, what 2 ideas? Number 1, stop at the first sentence. Don't read any further.
People and hot dogs.
People and hot dogs.
Hot dogs are big and people are small.
No, that only works if the first word is all. When you're talking about some, what does the picture change into?
So the
The
first
other
one is
way
big
around.
and the other one's small.
But go back to where I said all A's or B's, no A's or B's, some A's or B's, intersecting. Intersecting. So when I draw hot dogs, I always start with the second one. Hot dogs. The second one I'm going to draw just has to intersect it. So here is people. That's the other idea, people. So let me ask you this. If I'm in this sector 1, remember sector 1? If I'm in sector 1, what am I?
A person
I'm a person
that don't like hot dogs.
that does not like hot dogs. If I'm in their intersection, sector 2, I am
A person
a person
that likes hot dogs.
that likes hot dogs. If I'm in sector 3,
You're not a person.
I'm not a person,
But
but
you like hot dogs.
I like hot dogs. And if I'm out in sector 4,
There is no sector 4.
if you're not a person, what are you? Well, you could be a dog, you could be a cat, you could be a cow, you could be a moose, you could be a tree, you could be a rock, anything that's not a person.
Okay, so with the hamburgers, you draw another circle.
Yeah, I'm getting there. But I just wanted to describe what every little piece of this represents. So here we have people that don't like hot dogs. Here we have people that do like hot dogs. Here we have something that likes hot dogs. Here we have something that does not like hot dogs. If you're outside, you're something that is not a person that does not like hot dogs. Kind of a weird way of thinking about it. Now, we get to the second sentence. Second sentence. Some people like hamburgers. What circle do I not have to redraw? People. People's just stays there. It's already been drawn. I don't need to draw another circle representing people. But now I have some people liking hamburgers. So where do I put them?
At the third, at the
On
bottom.
the other side.
Yeah, you can put it like a regular
Yeah.
Venn diagram setup. And we can call this hamburgers. Is that the only place that I can put that black circle? I could put it up beside people over here and not even touch that green circle at all. Because here's some people that like hamburgers. So how many pictures did I just come up with? One too many. One too many. Because I can move that black circle away from the green circle so that I don't have anybody that likes hamburgers liking hot dogs. Or I could have some people liking hamburgers and hot dogs. I have 2 possible outcomes. Therefore, this is invalid.
Is it okay to draw both of those circles, the black circles, or just one?
I need you to.
You need me?
I need you to say it could be here or it could be there. Therefore, it's invalid. If you just draw the one circle and say it's invalid, you drew one picture. That means it should be valid. So you have to think of all the different possibilities. Some people. Number 10. Number 10.
186, number 10.
186, number 10. I'll write it down on the board.
Wait.
Newton.
We didn't cover shit. We didn't cover none of that.
Wait a what?
We didn't cover that.
We didn't do all and some?
Not
Yeah, not
together.
together.
We did them
the same
separate.
way.
Draw pictures. Don't worry about what I've done. I've showed you all you need to know. Just try. You jump on it and go, oh my God, it looks different, therefore I don't know how to do it. My God, that stove is totally different than the one I had before. I don't know how to use it. You figure it out. All
You just like switch it up. That makes
are funny people. Don't worry about if it's true or false. You don't care. Some funny people are professors. Therefore, some comedians are professors. Don't worry about it making sense or not. Try to draw it. I'll give you 10 seconds. 10 seconds is all you need to draw a few circles. Remember, do it one line at a time. You draw a picture for the first line. And this one will eventually have 3 circles. Because you have comedians, you have funny people, and you have professors. Those are the 3 things you're looking for. You didn't give me a valid or any color. Oh, is it written? I want you to like.
Yes, it's an invisible ink.
I love invisible ink. Valid?
Invalid.
You didn't label your circles. How am I supposed to know what's inside? You know, remember English? You took English, right? Writing papers, and you're supposed to write papers because, in a way that other people could figure out what the heck you're talking about. Math is the same way. If I look at it and I don't know what the heck you did, I don't know what the heck you did. All comedians are funny people. What circle's big? Funny. So let's put funny here. What goes inside of funny? The comedians, funny people. I'm abbreviating. So comedians go inside. I'll just call them com. So here we have all comedians are funny people. Great. Second sentence. Some funny people, that means some of these blue people, are also professors. So where can I put the professors?
On the outside.
On the outside, but it has to intersect the blue circle. So either I can put my picture here and have that be my professors. Where else can I put them?
With the comedian and the funny people.
I can run into the comedians and the funny people. So this also becomes professors. Therefore, this argument is invalid because I came up with 2 possible places to put Mr. Professor. Maybe he is, maybe he isn't, but there is no guarantee.
I got a question.
Go for it.
But it doesn't say that professors are necessarily comedians.
Right.
So why would you go into that circle?
Because the only thing the sentence says is some funny people are professors. So how deep does this black circle go? I don't know. So it could not touch the green, or it could touch the green, and that's why it's invalid.
Because some funny people are comedians.
Just because some funny people are professors. All I have to do is have that black circle touch the blue circle. That's all I have to do.
So some funny people can be comedians and professors.
You're not looking at it the right way. I don't know anything about the green circle at all. All I know is the black circle runs into the blue circle. Now, how far it runs into the blue circle, it could run into it a little bit, it could run into it a lot. But I don't know. So I can either have it not touching the green circle, or I can have it touching the green circle. But because I can have it in both places, this argument is invalid. Like I said, you either get it, or you don't for some reason. I don't know why. Oh, the only one that you get big small is when the first word is all. Then the second one is the big one, automatically.
Oh, okay.
The second idea is the big one.
Small.
The one next to all is going to be the small one.
Oh, okay.
All shoes are big. Well, shoe is going to be small, and big is going. Yeah, big is going to be big. I shouldn't use that sentence.
Comedians, then, if the professor works comedian.
No. Do number 12. You're getting ahead of me. Number 12, which is the same thing. Okay. All comedians are funny people. Some comedians are professors. Therefore, some funny people are professors. All they did was change some words around. Write that down. Well, it's the same as the first one. And then it's some comedians are professors. Therefore, some funny are professors. So it's using the same three circles. Let's just change some things around. Better if you read it in your book, because I didn't write it all out. The first sentence is exactly the same, so that picture is not going to change. Funny.
That's valid.
And inside it is comedians. So here's comedians. Now that second sentence is totally changed. The second sentence says some comedians are professors. So when I draw my professors, what does it have to run into?
Comedians.
The green circle. So it's got to run into the green circle no matter what I do. This black circle has to touch that green circle. Can it come over here like the other one did?
No.
No. So here's my professors. And because it's touching the green one, it's also touching the blue one. Therefore, some funny people are also...
Professors.
Some funny people are professors. Therefore, the argument is
Valid.
valid, because I'm only going to get one picture out of this whole thing. That's the big difference between them. It really depends on if it can go in two locations or if it can go in one. If it can go in one, valid. If you could force it into two different pictures. Now that black circle, I can move many, many different places, but it would still be intersecting either the blue or the green, so be careful of that. Okay. Homework. Lots of it. Tons of it. Now, section 3A, the homework doesn't take much. All you have to do is draw a bunch of circles, but don't draw them quickly. One sentence at a time, and be very cautious about where things go, because that'll determine if you get it right or if you get it wrong. I don't allow flipping of a coin, so if you see a question and you write valid, I do not give you credit for it, whether it was valid or invalid. I need to see where you got your answers. Speaking of that. Yeah. Which one? When they said some comedians are professors, the only place I could take the professor circle is to run it into the green one. It's the only place it could go. So once I run it in the green one, it automatically runs in to the blue one, therefore it's not going to go anywhere else. I can take that black circle and move it all around, but it still has to touch that green one. That's still just one picture. See, this picture is the same as this picture. Those are not two separate pictures. They're the same thing. They're both running into the blue and the green, the blue and the green. So that's not what I'm talking about, two separate pictures. The one over here, it either runs into the green or it doesn't. That's two separate ideas.
Okay.
Therefore, that's invalid, where that one, I can move that black circle anywhere I want, but it still has to touch that green thing. And therefore, it's going to be valid all the way.
Okay, thank you.
Like that second sentence of number 12,
Uh-huh.
where it says
Some
comedians.
comedians are professors.
You wouldn't just intersect it with the comedians, right? You could
Oh,
do
I could have it in here like this. Yeah, you could do that. But even then, actually, that becomes even worse. That becomes all funny people. No, that's still some professors are funny. I'm sorry, some funny people are professors. Because this is all the funny people, and this would just be some of them.
Okay.
So yeah, it's still hitting the green circle, but it's still hitting the blue. So this is just more definite to be blue.
Okay.
Because then this becomes all professors are funny, but I don't care.
And it's still valid like
That's
that.
still valid because you only had one picture. Yeah, you can't force it away from the last sentence being one or the other, true or false. You want it to be either all true, all the time, just like other arguments, always true, always.